First, let us define quadratic equations. Quadratic equations are of this standard form: ax squared plus bx plus c equals 0. But a should not be equal to 0. It means in a quadratic equation, there is a term with a variable raised to second power. Example, 2x squared plus 9x minus 5 equals 0. In here, our example is in standard form. All the terms are on the left side and it is equal to 0. Then we can collect the a, b, and c. Take note that the a is the coefficient of x squared. So a equals 2. The b is the coefficient of the x. So in here the b equals 9. And the c is the constant. So c is equal to negative 5. Do not forget the sign of the constant. Let us see now the quadratic formula. The solutions to a quadratic equation of the form ax squared plus bx plus c equals 0, where a is not equal to 0, are given by the formula, and this is the quadratic formula. X equals, in the numerator, is negative b plus or minus the square root of the quantity b squared minus 4ac all over 2a. Here are the steps on how to solve quadratic equation using quadratic formula. Step 1. Write the quadratic equation in standard form. Identify the a, b, and c values. Step 2. Write the quadratic formula. Then substitute the values of a, b, and c. Step 3. Simplify. Let us have some examples. This is example 1. Solve 2x squared plus 9x minus 5 equals 0 by quadratic formula. In solving, it means we want to get the values of the x. Step 1. Write the quadratic equation in standard form. The equation is already in standard form because all the terms are on the left and it is equal to 0. Identify now the a, b, and c values. So we will collect the a, that is the coefficient of x squared, it is 2. We collect now the b, the coefficient of x, and that is 9. And the c is the constant, negative 5. Step 2. Write the quadratic formula. Then substitute the values of a, b, and c. Here now is our quadratic formula. And then we substitute the values of a, b, and c. It is now the negative of b, and that is 9, plus or minus the square root of, this is now 9 squared, minus 4. The a is now changed into 2. The c is now negative 5 all over 2 times a, and the a is now changed into 2. And step 3, we will simplify and get the values for x. So the negative of the positive 9 is now negative 9, plus or minus 9 squared is 81, the product of -4, 2, and -5 is positive 40 all over 2 times 2 is 4. Then we simplify the radicand. The 81 plus 40 is 121. We just copy the -9, the plus or minus sign, and the denominator 4. On the next step, we need to simplify this square root of 121, and that is 11. Now at this point, we're going to split the plus and minus. There will be two values for the x. The x sub 1 is equal to, we will use first the plus sign. So -9 plus 11 all over 4. For the x sub 2, the negative sign will be used. So -9 minus 11 all over 4. Then let us simplify both. -9 plus 11 equals positive 2 over 4. The -9 minus 11 equals -20 over 4. We can reduce to lowest term the 2 over 4. It is equal to 1/2. The -20 over 4 is equal to -5. So the two values of x are 1/2 and -5. Let's have example 2. Solve x squared minus 6x equals -5 by quadratic formula. Step 1. Let us write the equation in standard form. We can see here that the constant -5 is on the right. The standard form says the right side must be equal to 0. So we will transpose the -5 to the other side of the equation, and the sign must be changed. So the -5 becomes +5 on the left side, and it is equal now to 0. Then we will identify the a, b, and c. For our a, the coefficient of x squared is 1. The b, the coefficient of x is -6. And the c is the constant. Step 2, we go now to our quadratic formula. Then we will substitute the values of a, b, and c. So it's now negative of -6 plus or minus the square root of the square of -6 minus the constant 4 times a, which is now changed into 1, times c, which is now changed into 5, all over 2 times a, and a is 1. Step 3, let us simplify. The negative of -6 is +6, plus or minus the square root of the square of -6 is +36 minus the product of -4 times 1 times 5 is -20 all over 2. And then we will simplify the 36 minus 20. It is now 16. So our radical now is square root of 16. And then we can simplify the square root of 16 into 4. And from this point, we're going now to split the plus and minus sign to get the two values of x. X sub 1 equals 6 plus 4 all over 2, and x sub 2 equals 6 minus 4 all over 2. For the x sub 1, the 6 plus 4 is 10 over 2, which is equal to 5. For our x sub 2, the 6 minus 4 is 2 over 2, and that is equal to 1. And this is our final answer. Now let us consider example 3. Solve x squared equals 8x minus 16 by quadratic formula. Step 1. Let us write the quadratic equation in standard form. It means the 8x minus 16 we will transpose on the left side. If we do that, we should change the sign. Look at the 8x. It becomes negative 8x here, and the negative 16 on the right becomes positive 16, and it is now equal to 0. Then let us identify the a, b, and c values. A is the coefficient of x squared. It is equal to 1. B is the coefficient of x, and that is negative 8. And the c, the constant, positive 16. Then we will write the quadratic formula and substitute the values of a, b, and c. So this is now the negative of negative 8 plus or minus the big square root. The square of negative 8 is here, then minus 4 times a, which is now changed into 1, times c, which is now changed into 16, all over 2 times a, and is now changed into 1. Then step 3, we will simplify the formula. The negative of negative 8 is positive 8, plus or minus the square root of the square of negative 8 is positive 64. Then minus the product of 4 times 1 times 16 equals 64. All over the 2 times 1 is 2. You see here we have 64 minus 64, and that is equal to 0. So our radical now is square root of 0, and when we simplify the square root of 0, it's simply 0. At this point, we will now split our x into plus or minus. The x of 1 is 8 plus 0 all over 2. 8 plus 0 is 8 over 2 is equal to 4. X of 2 is the 8 minus 0 all over 2. Also it is 8 over 2, and that is equal to 4. You see here our values are the same. It's like the solution of the quadratic equation is simply a single number, and that is 4. This is our final answer. Take note, in a quadratic equation, since the highest power is 2, the number of possible solutions is at most 2. Example 4. Solve 2x squared plus 10x plus 11 equals 0 by quadratic formula. We have our formula in here. Now let us collect the values of a, b, and c. The a is the coefficient of x squared, so we write here a equals 2. The b is the coefficient of x, and this is positive 10. And the c is the constant 11. Then we substitute the values a, b, c in our equation. So we have x equals the negative of 10 plus or minus the big square root 10 squared minus 4ac, and that is 4 times 2 times 11 all over 2a, that is 2 times 2. We simplify further. This negative of 10 is simply negative 10 plus or minus the square root of 10 squared is 100 minus the product 4 times 2 times 11. That will be 88. All over 2 times 2 is 4. We simplify the values inside the radical symbol. 100 minus 88 is 12. Now we simplify the square root of 12. This is not a perfect square number, so we simply take the factors of 12, one of which must be a perfect square number. So we have the square root of 4 times 3. And we know the square root of 4 is 2. We can pull it out this radical sign. So we have now 2 square root of 3. In the numerator, there is a common factor, and that is 2. We can factor it out. So we have 2 times the quantity, negative 5, plus or minus the square root of 3, all over 4. We can cancel the 2 and the 4. So this 2 becomes 1, and this 4 becomes 2. We simplify further. X equals negative 5 plus or minus the square root of 3 all over 2. Now we're going to show the two values of x. The first value will use the positive. The second value will use the negative. So x sub 1 equals negative 5 plus square root of 3 all over 2. And x sub 2 equals negative 5 minus the square root of 3 all over 2. This is our answer. Example 5. Solve 3p squared plus 2p plus 9 equals 0 by quadratic formula. Our quadratic formula is here. Now let us collect the values of a, b, and c. The a is the coefficient of p squared, so we write a equals 3. b is the coefficient of this middle term, so this 2 is the value of b. And the c is the constant, so we write here c equals 9. We substitute the values a, b, c respectively in the equation. So we have x equals the negative of positive 2 plus or minus the big square root of 2 squared minus 4ac. So we write here 4 times 3 times 9 all over 2a. So we have 2 times 3. We simplify further. This negative of 2, we simply write minus 2 or negative 2 plus or minus the square root of 2 squared is 4 minus the product 4 times 3 times 9, and that will be 108 all over 2 times 3, that is 6. We simplify the values inside the radical sign. 4 minus 108, and that will be negative 104. When we simplify this square root, we say that we cannot take the square root of a negative number. So that means we will conclude that the given equation has no real solution. Today we're going to study discriminant. Let us define discriminant. In the quadratic formula, this is the quadratic formula, the quantity b squared minus 4ac. This is the radicand of the radical in the quadratic formula. That is called the discriminant. For a quadratic equation in standard form, ax squared plus bx plus c equals 0, and a is not equal to 0, we are going to use the discriminant to predict the number and nature of solutions of a quadratic equation. If the discriminant b squared minus 4ac is greater than 0, it means the discriminant is positive. The equation has two real numbers and distinct solutions. Or we can say that there are two answers, and these two answers are real numbers. If the discriminant is equal to 0, the equation has two real and equal solutions. In other words, we can say that there is one real solution. If the discriminant is less than 0, or we say that the discriminant is negative, the equation has no real solution. Let us determine the number of solutions to each quadratic equations. This is the first one. 3x squared plus 7x minus 9 equals 0. We're going to follow these three steps. First, let us write the quadratic equation in standard form. We can see here that the problem is already in standard form. Then we will identify the a, b, and c values. The a is the coefficient of x squared, and that is 3. The b is the coefficient of x, that is positive 7. And the c is the constant, it is negative 9. Next, we will write the discriminant formula, and we will substitute the a, b, and c values. So the b squared is now the square of 7 minus the constant 4 times a, which is now changed into 3, times the c, which is now changed into negative 9. Then we will simplify. The 7 squared is 49 minus the product of 4 and 3 and negative 9. So the answer is positive 108. Then 49 plus 108 is 157, and this is a positive number. Since the value of discriminant is positive, there are two distinct real solutions to the equation. Let's have example 2. 9x squared plus 1 equals 6x. First, let us write the quadratic equation in standard form. So this positive 6x on the right side of the equation is transposed to the left side, and the sign is changed. It is now negative 6x, and the right side is now equal to 0. Then we will collect the a, b, and c values. The a is the coefficient of x squared, that is 9. The b is the coefficient of x, that is negative 6. The c is the constant, positive 1. Then we will write the discriminant formula and substitute now the values of a, b, and c. The b squared is now the square of negative 6 minus the constant 4 times a, which is now changed into 9, times the c, and now changed into 1. Then we simplify further. The square of negative 6 is positive 36 minus the product of 4 and 9 and 1 is 36. So we have 36 minus 36 equals 0. Since the value of discriminant is 0, the solutions are equal. Or we can say there is one real solution. Let us have example 3. The monomial x times the binomial 5x plus 1 equals negative 4. First, let us write the quadratic equation in standard form. The x here will be multiplied to each term of the binomial. So we have the x times 5x is 5x squared plus x times 1 is x, and then the negative 4 on the right side is transposed on the left. The sign will be changed. From negative, it becomes positive, and this is equal to 0. Then we will identify the a, b, and c values. The a is the coefficient of x squared, that is 5. The b is the coefficient of x, and that is 1. And the c is the constant, positive 4. Then on the discriminant formula, we will substitute the values. The b squared is now the square of 1 minus the constant 4 times a. The a is changed into 5 times c. The c is now changed into 4. Then we will simplify further. 1 square is 1 minus the product of 4 and 5 and 4, that is equal to 80. 1 minus 80 is negative 79. Since the value of discriminant is negative, there is no real solution to the equation. Example 4. The equation is 2v squared minus 3v plus 6 equals 0. Notice that the right side equals 0. So this is in standard form. That means we can collect the values a, b, and c respectively. The a is the coefficient of v squared. So we write a equals 2. B is the coefficient of this middle term, so negative 3. And the c is the constant 6. Now we show the formula of discriminant, b squared minus 4ac. We substitute the corresponding values. So we have b squared, that is the square of negative 3, minus 4 times a times c. So we have 4 times 2 times 6. We simplify. Square of negative 3 is positive 9, minus the product 4 times 2 times 6, that is 48. 9 minus 48 is negative 39. We can see that the discriminant is negative. So we say, since the value of discriminant is negative, there is no real solution to the equation. Let us have more sample problems. Problem 1. Solve by using the quadratic formula. 4m squared plus m minus 3 equals 0. Our variable is m, and this is the formula. Now let us collect the values for a, b, and c respectively. For the a, that is the coefficient of m squared, and that is 4. For the b, coefficient of m, we write here 1. For the c, that is a constant negative 3. Let us now substitute these values in the formula. So we have negative 1 plus or minus the square root of 1 square minus 4 times 4 times negative 3 all over 2 times 4. Then we simplify. This negative of 1, we write minus 1 plus or minus the square root. 1 square is 1. Then we multiply negative 4 by negative 3. And that will be positive 48 all over 2 times 4 is 8. Inside this radical, we combine 1 plus 48. That will be 49. Then we simplify the square root of 49, and that is 7. When we reach this point, we're going to split now the values for the m. One using the plus, the other using the minus. So we have m sub 1 equals negative 1 plus 7 over 8. We simplify this. The numerator becomes positive 6 over 8. And we simplify this fraction into 3 over 4. For the m sub 2, we're using the negative sign. So negative 1 minus 7 divided by 8. In the numerator, it becomes negative 8. Then we divide by 8. The answer is negative 1. These are the two values for the m. Problem 2. Solve by using the quadratic formula. 2a squared minus 6a plus 3 equals 0. In this case, the variable is a. So we can do like this, just to differentiate it with the a that we have on the right side. We collect the values now for a, b, c. For the a, that is the coefficient of this a squared, we write here 2. For the b, the coefficient of this a, the negative 6. And for the c, the constant 3. Let us now substitute these values in the formula. So we have the negative of negative 6 plus or minus the square root of the square of negative 6 minus 4 times 2 times 3 all over 2 times 2. We simplify further. The negative of negative 6 is positive 6 plus or minus the big square root, the square of negative 6, positive 36, minus, we multiply 4 by 2 by 3. We will get 24. All over 2 times 2 is 4. Simplifying this 36 minus 24, we get the answer 12. Note that the square root of 12 is not a perfect square value. So we can simplify this anyway by showing that 12 equals 4 times 3. Since 4 is a perfect square number, we can simplify it by moving it outside the radical. So it becomes like this. 2 comes out, then the square root of 3. Note that in the numerator, there is a common factor, and that is the number 2. We factor it out, then multiplied by 3 plus or minus the square root of 3, all over 4. Then we can cancel this number 2, it becomes 1, and the number 4, that becomes 2. So we have 3 plus or minus the square root of 3 all over 2. From this point, we can now separate the two values for the a. One using the plus, the other using the minus. So we have like this. A sub 1 equals 3 plus the square root of 3 all over 2. And the a sub 2 equals 3 minus square root of 3 all over 2. Problem 3. Solve by using the quadratic formula. 3t times the quantity t minus 2 equals 2. At this point, we want to convert this into standard form. First thing we do, this 3t we multiply to the terms inside the group. So 3t times t is 3t squared. Then 3t times negative 2 is negative 6t equals the constant 2 on the right. Let us now make this in standard form. Let's make the right side to be equal to 0. The constant 2 we transpose to the left. So it becomes negative 2 and this is now equal to 0. From here we can now collect the values for A, B, and C. A is 3, B is negative 6, and C is negative 2. This is now the quadratic formula with regard to t. Let us now substitute the values. So we have the negative of negative 6 plus or minus the square root of the square of negative 6 minus 4 times 3 times negative 2 all over 2 times 3. Let us simplify further. The negative of negative 6 is positive 6 plus or minus the square root of the square of negative 6 is positive 36. Then we multiply negative 4 times 3 times negative 2. We get positive 24 all over 2 times 3 is 6. We get the sum of 36 plus 24, that would be 60. Then let us simplify the square root of 60. We know that this is not a perfect square number, but we can show this 60 to be 4 times 15. That means we can simplify this number 4, putting it outside, and it becomes 2 times the square root of 15. In the numerator, there is a common factor, and that is 2 times this 3 plus or minus the square root of 15 all over the number 6. We can now cancel the number 2 with the number 6. 2 becomes 1 while 6 becomes 3. So 3 plus or minus the square root of 15 all over 3. At this point, we can now split the values for t, one using the plus, the other using the minus. So t sub 1 equals 3 plus square root of 15 all over 3. T sub 2 equals 3 minus the square root of 15 all over 3. Problem 4. Determine the number of solutions to quadratic equation 6m squared plus 3m minus 5 equals 0. This number of solutions can be solved by the discriminant principle. We have the formula, that is b squared minus 4ac. Let us first collect the values for a, b, c respectively. A, coefficient of m squared, that is 6. B, coefficient of m, we write here 3. C is the constant negative 5, and this is it. We substitute the values in the formula for discriminant. So we have 3 squared minus 4 times 6 times negative 5. 3 squared is 9, then negative 4 times 6 times negative 5, that is positive 120. The sum is 129. So we say that since the determinant is positive, the quadratic equation has two distinct real solutions. Problem 5. Determine the number of solutions to this quadratic equation. 4u squared minus 12u plus 9 equals 0. We write our determinant formula, then we collect the values for a, b, and c. A is 4, b is negative 12, and c is the positive 9. Let us now substitute the values in the formula. So we have the square of negative 12 minus 4 times 4 times 9. So the square of negative 12 is positive 144 minus 4 times 4 times 9 is also 144. And the difference is 0. By the rule, since the determinant is 0, the quadratic equation has one real solution.